All right, so for the two terms, we're going to look for greatest common factor. And then after we do that one, we'll go from this one. So now, again, greatest common factor is basically this. And there's only two options for this thing. And this part is a lot similar back here. Probably doing over, probably should have done this part of it first. We got 2x to the third minus 6x squared. Okay, so again, we know we divide 6 and 2, we can divide them both by 2. And again, we're going to take out the smaller amount of x's, so x squared. So that would make that 2 divided by 2 would be 1. Take out 3 x's, or take out 2 of the 3, that'll leave us with an x. And then we're doing 6 divided by 2 to make that out to be a 3. I took the x's there. So again, what we're doing is once we figure out that it's 2x squared, we're going to go back and divide them both by 2x squared. And you cannot see that because of the shine on the red paper there. Okay, now, so in some of these, they may ask for just the GCF. If they ask for just the GCF, it would be 2x squared. If they say to write it in factored form, you would put the whole thing there. Oh, okay. So, correct, yeah. So if you've got 6 and 2, what can you divide both of those two numbers by?
Oh, okay. So it's basically what you divide.
Yep.
That's what we did over here, but only one.
Yep. So it's like half of what we were doing earlier, kind of thing.
Okay.
Okay. All right. Now, most of these.
That makes sense because we divide both sides by that number.
Correct.
And then in the first like we thought we could get from dividing both sides. That makes more sense.
Okay. Now, most of the ones that you're going to do with two terms are not going to be that way. They'll throw one of these in just to be sneaky on most of these. Most of the ones you're going to do are going to be doing difference of perfect squares. Okay, and what that's going to look like is something like this. It's going to be x squared minus 49. All right, now here's where this is really, really easy. And here's what you're gonna look for in all these two terms, things that you do. If it's perfect squares. So basically, on your calculator, we've got 49. See if I can get that's clear here. If it's perfect squares, we're gonna do the square root of that number. And calculator's not on, so that's not gonna happen. There we go. Calculator's on now. Okay. Because if we do the square root of 49, that's 7. So if you've got 49, just think that that's 7 times 7, right? If you've got x squared, that would be x times x. So if when they talk about perfect squares, that's what you're looking for. So it's going to be some variable squared, and you're going to have some number times some number. And it's always the same number times itself. So when you write these out, to make this a negative 49, all you're going to do is you're going to put x plus one of these numbers and x minus one of the other numbers. And usually people ask, what else? That's it. That's all you do. Okay. Okay. So what we're gonna do, we're just gonna practice on this one. And as long as you can think about that, you're just gonna do some number times itself. And again, the big thing is it will always be a minus in the middle. So this one we're gonna do y squared minus 100. Because 100 is, yeah, 100 is 10 times 10. Yep. Yep. Y squared.
So in both differences, y plus 10.
And then the other one will do y
Y plus 10.
minus 10.
Minus 10.
Yep. Always plus minus. Because to make it a negative number,
Oh.
we got to do a positive times a negative. That's what works out.
That makes more sense.
Okay.
Well, what about for positive numbers? Would they both be plus?
That's a different thing for a whole different thing we'll talk about later on. But right now, everything will be minuses on those. Okay, let's give you another here. A little different look, but along the same lines here. 4t squared minus 81. Yep, still the difference of perfect squares. Because 81, you can make it 9 times 9. 4 is 2 and 2. Now, the difference is this time we're going to do 2t and 2t. So you still need the variable twice. You need the number twice based on that one. Okay, and since it's negative 81, yep, we know it's going to be plus and minus 9. And then whatever this number is here, it'll be the same. So it'll be 2t and 2t. All right. And somebody's saying, what's the trick on this one? There's not really any tricks to this one. So if it's two terms, if there's only two numbers there, two terms for this thing, you're looking for a perfect square. If it's not a perfect square, then all you're going to do is you're just going to take out a greatest common factor like this. Now, let me show you one. This will be the last one we'll do here. There is one where you actually kind of do both of these together. So go 2x squared minus 50. Okay, so is 50 a perfect number? Close, right? Not quite. Because we know 49 is, but 50 is not. Because you can't do, and again, if you're not sure, just get the number out and check it. So we'll do calculators off again. And again, if you're doing square roots on here, on the calculators, we've got you hit the second button up here, and then your square root is right here with the x squared button. And if you check square root of 50, you get a decimal number. That'll let you know it's not a perfect square root. So that one's out. So here's what you got to do. If it's not a perfect square root, they're both even numbers, right? 2 and 50. So you could divide them both by 2. So we divide them both. We're going to take out a greatest common factor of 2. If we divide them both by 2, that'll make that x squared. And then 50 divided by 2 is 25. All right, and if you cover up the 2 for just a second, are those perfect square numbers? Because 25 is 5 times 5. X squared is x times x. So we're going to do 1x plus 5. One of them is x minus 5. And somebody says, what about the 2 that's out there? That 2 that was hanging out outside the parentheses, you still just let it hang out outside the parentheses there.
Wait, so what happens if it's a positive number?